All right, so our topic for the rest of today is kinetic energy. I'm just going to take a couple of minutes and talk about the formula, which is on your formula sheet. Kinetic energy, like a lot of you already knew, is the energy of motion. And so yesterday, one of the questions that you had to answer was, why is potential energy not as obvious as kinetic energy? And the response was, well, because in kinetic energy, something's moving and that's easy to see. And in potential energy, things are not moving and that is difficult to observe. So if I asked you to describe what kinetic energy is, it's the energy of motion. If something is moving, it has kinetic energy. And kinetic energy is a function of the mass and the velocity or speed of the object. We could use a vector or a scalar measure for velocity or speed, and we would have the same formula. Typically, it is written without the vector arrows. And the formula is EK, so the E for energy, the K for kinetic, which is measured in joules, is equal to 1/2 mv squared. And so I'd like to show you a couple of other ways that you could write this same formula that mean the same mathematical thing. I don't know if you're like me, but I never learned how to make my calculator do fractions because I'm like 100 years old and I don't like to type them. So when I type this in my calculator, what I actually type is 0.5 mv squared. It's the same thing. That's what half is. 0.5 is the decimal number that goes with half. If you wanted to, you could do this. You are doing the same mathematical operation. You could also do mv squared divided by 2. It's the same thing. So that little half symbol at the beginning means that somewhere along the line, I need to multiply mass and velocity squared and then take half of that value by multiplying it by 0.5 or by dividing it by 2. Since this is the version that you generally see later in life, that's the one that I'm writing on the formula sheet. But so that you know, alternatives for when you're typing this into your calculator would be those two versions there. Now, just like in potential energy, mass absolutely must be in kilograms. There are 1,000 grams in 1 kilogram. That means to go from a gram to a kilogram, you divide by 1,000. To go from a kilogram to grams, you multiply by 1,000. So it's very realistically possible that you'll have to change that unit. Velocity or speed needs to be in meters per second. That's not typically a unit that I would want you to change from something else, but I would realistically ask you to convert mass. Now you'll notice I have a picture of a roller coaster for a number of reasons. A, they're awesome, but B, a roller coaster is going to be a really good example for us because it shows kinetic energy as it's going down, but it also shows potential energy because it goes up really high in the air. And so you'll see that as we do the next couple of lessons, I will mention a roller coaster a number of times because it's an excellent example to show both kinds of energy in action. Would anyone like to ask any questions about the formula for kinetic energy or the units? So we're going to do our 4 practice problems. They're on the sheet that I passed out to you that had that list of practice problems. So you shouldn't have to copy the problem down. Simply follow along with the solution for how to answer it. Now I'm going to show you 4 practice problems instead of just 3. And it's because the last 2 are kind of similar. They're asking you to calculate the same thing, but it's the thing that's hardest to calculate. So I like to do 2 so that you can try one by yourself after I show you the example. So in all of these questions, we're going to be using the kinetic energy formula. In the first question, It is asking me to calculate kinetic energy, so I know that's what I'm looking for. I have a mass that is already in kilograms, which is perfect. I don't have to change it. And I have a speed. Now you'll notice in a lot of these questions that we say that the speed is constant or uniform, and that's because if it weren't, I wouldn't be able to do this calculation. And so we're going to assume for all of our questions, if I'm asking you to calculate kinetic energy, that the object has a constant rate of speed. Otherwise, you can't use the value of speed that's given. So my formula is that kinetic energy is 1/2 mv squared. So I'm going to fill in the numbers that I'm going to actually use. 1/2, or you could easily write 0.5, doesn't matter to me. And then I want you to notice that I have the habit of putting brackets around things. And the reason is, especially in a question like this, anytime there are exponents kicking around, I like to make sure that I'm keeping them with the number that they go with. So I want to make sure that 10 to the power of negative 31 goes with 9.11. And the only way I can make sure of this in my calculator and in my mind is to separate it. The other reason I like brackets in this question is specifically for the second part. My speed already had an exponent on it, and I need to put this to the power of 2. It would be weird to write the exponent without brackets. And so in particular in this formula, because I know I always need to put this second value, the speed, to the power of 2, I put the numbers in brackets so that I can see them separately, and I don't mix up where all of the exponents go. So when you type this into your calculator, you really need to be careful when you're using scientific notation. It's a constant struggle, I think, for some people to correctly input this into their calculator. There are a number of ways that you can type it, but the way that I always use, so on the bottom here, this is what I would type in my calculator, 0.5 times 9.11 e negative 31. The e means times 10 to the power of, times 2e5 to the power of 2. It's especially important for the second value that you put brackets around it. Otherwise, it's going to think that your exponent is 52, and you need to differentiate between 2 times 10 to the power of 5 and the fact that I want to put that whole number to the power of 2. If you've typed this correctly into your calculator, the value that you should be getting, get my correct page here, is 1.82 times 10 to the power of negative 20 joules. So I'm just going to, all right, I think I've checked people's calculators, so we'll go on to the second and the third examples. The second example is giving you speed, so there's your V. It's giving you kinetic energy, so there's your EK, and it's asking you mass. So we're going to use the same formula, but we're going to have to rearrange it, and I'll just show you how I rearrange it. If I start with the original formula, I want m to be all by itself. So that means I have to start moving things, and to get rid of things, I have to do their mathematical opposite. So to get rid of this half, or 0.5, I multiply by 2 on both sides of the equation. That cancels it out over here and puts 2 on the other side. To get rid of v squared, I divide both sides by v squared. So it gets canceled out on one side and then shows up on the bottom on the other side. That means that my formula for mass is 2 times EK over V squared. Now, if you were using 0.5 instead of a fraction, you might have EK divided by 0.5 times V squared, which means exactly the same thing. So I'm just showing you two versions depending on what way you were representing the half. So our calculation for the second one then would be that mass is 2 times 18 joules divided by 2.2 meters per second, and that has to be squared. Now you'll notice I put brackets around it even though there's only one number and even though there's not already an exponent, and it's because I don't want to forget the power of 2. Meters per second squared is a unit, and sometimes if I don't make the 2 very apparent, we forget it. So in your calculator, you should do 2 times 18 divided by 2.2 squared. The answer that you should get is 7.4 kilograms. And so take a minute and type this into your calculator and make sure that 7.4 kilograms is what you are getting. All right. So would anybody like to ask any calculator-related questions or formula-related questions so far? So the third and fourth examples will be done with the same calculation. The reason I put 2 of them is because this is the manipulation that people find the hardest. I have a mass. Now I know that my mass needs to be in kilograms, not in grams. To go from grams to kilograms, I divide by 1,000. So that means I have 0.3 kilograms. I know my kinetic energy, it's 304 joules, and I would like to calculate the speed. So I'm using the same formula, but this time I have to isolate V, and that's a little bit trickier. To isolate V, I start the same way as I did for M. Instead of this 1/2, I'm going to multiply both sides by 2. That way it will cancel out on one side, and I'll have a 2 on the other side. To get rid of the M, I'll divide by M on both sides. Those M's will cancel out. Now the last thing I need to do is get rid of the power of 2. To get rid of the power of 2, I have to do its mathematical opposite, which is a square root. So that means if I'm going to calculate V, V will be equal to the square root of 2 times kinetic energy over mass. And when you type this into your calculator, very probably your calculator will start a bracket for you. If it doesn't, make one. You need to make sure that that whole calculation happens first, and then we take the square root of it as the last step. So that is how you calculate V. My procedure was the same. If I want to move something from one side of the formula to the other or get rid of something, I do its mathematical opposite, and I do it on both sides. So there's my formula that I'm going to use. If I'd like to calculate the speed then, I will do the square root of 2 times 304 joules divided by 0.3 kilograms. So again, don't forget, make sure if your calculator doesn't start one, you start an open bracket and that whole calculation happens inside. Let me just write down the answer. It's 45 meters per second. See if you can get that answer. If you can, you've typed it in properly.